So right here is a great example. If it says 25x squared minus 36y squared, let's see if we can find a and b. There's no GCF, so now we're going to figure out what a and b are. What number squared is 25? It's a 5. X has to go here because x squared is x squared. What squared is 36? 6. And this has to be a y. Since you can find a value for a and b, we can fill in our formula, which is a plus b. So if a is 5x plus our b value of 6y is equal, times a minus b. So 5x minus 6y. If you decide to distribute and FOIL, you'll end up getting the same result as the original problem. You will get 25x squared minus 36y squared if you distribute, right, and simplify. Now, for the square of a sum, what this is saying is if you have a quantity squared, you don't write a squared plus b squared. You don't do that. Example, if you see the quantity 3x plus 4y squared, make sure you write it 2 times. So I'm going to write 3x plus 4y times 3x plus 4y. And when I distribute, I get 3 times 3 is 9, x times x is x squared. 3x times 4y, 3 times 4 is 12, and then I have the variables x and y. 4y times 3x, 4 times 3 is 12, and then you can write x, y. It doesn't matter the order you write the variables in because it's x times y or y times x. Then 4y times 4y, 4 times 4 is 16, y times y is y squared. Let's combine like terms. So in here, we have 12xy and 12xy is 24xy. And you can't simplify any further. So that's our answer. Now, if you notice, what they show us here is if you see the sum quantity squared, you simply can look at the first term and consider that a, and then you'd fill it in here, a squared, you put an a there, and then you look at your second term b, and you can plug that in there and in there. So for example, if 3x was an a, right, what they're saying is in the first slot we can do a squared. So in the first slot they plugged a 3x and they squared it. So 3x times 3x is 9x squared. Then in the second area, it's 2ab, right? So they did 2, the a value is 3x, and the b value is 4y. And when you multiply that, 2 times 3 times 4 is 24, x times y is xy. Then in that last slot, they show you b squared. So they're saying if b is 4y, 4y times 4y is 16y squared. Let's continue on. Now, in Algebra 1, we usually don't touch upon cubes. Here we're going to look at sum and difference of cubes formula. Okay, so for squareds, right, we only have the formula for difference of squares. If that's a minus, we'd have x plus 5 times x minus 5. If we had the sum of squares, there's no formula. You can't simplify that, okay? Can't write x plus 5, x plus 5. So there is a formula, though, for sum and difference of cubes. Just like we did with squareds, you first find the a value, what cubed, the b value, what cubed, and then you'll plug into this formula in the a and the b spots. Let's look over here. So over here it says 8m cubed minus 27. You always look for a GCF first. Now for this problem, there's no GCF. I can't divide some same value out of 8 and 27. I see that cube, so I'm going to try to fit to the cube formula. So in the first slot, What cubed gets us 8? 2. What cubed gets us m cubed? Just m. So that's why we call that slot A. A is 2m. A is 2m. Okay, then in the next slot, we have a 27. We keep that negative in between. What cubed gets you 27? Okay, well that's 3. So your B value is 3. If you can fill the A slot and the B slot, then you can use the formula. The formula says A minus B. So over here, if A is 2m, A minus B is 3. Then they say A squared. So if A is 2m, 2m times 2m is 4m squared. Then if they say A times B, A is 2m times B is 3. So 2 times 3 is 6, followed by m. And in the last slot, we have B squared. If B is 3, 3 squared is 9, 3 times 3. So this is your final answer. Same thing for sum of cubes. There is a formula for sum of cubes. The only difference is you have that plus in between. So you're looking for a value cubed, and whatever you have in that slot is your A. You look for your other value cubed, and whatever you have in that slot is B, and then you plug into this formula. Over here, they show us a problem. There's no GCF. And we know this has to be a G. And what number cubed gets us 64? Well, it's a 4, and this has to be an H. So A is considered G, B is considered for H, and then we're plugging into the formula. A times B, A squared minus AB plus B squared. And you see that right here, plugging into the formula, A plus B, A squared minus A times B plus B squared. And then when you simplify, you get down here your final answer. Let's continue on. So for the next problem, how can we prove the sum of cubes identity? Well, if we know that they say that this is the formula, we can start to distribute and see if when we simplify, we get A cubed plus B cubed. So let's do that. I like to create that box. So on the outside, I'll do A squared, AB, B squared. I'm going to keep their sign. So A squared is positive, AB is negative. This is positive. And now over here, we'll have A and B. I'm going to multiply on the outside and add on the inside. Let me do a different color. So in this first box, I have A times A squared is A cubed. Over here, I have negative A squared B. Then I have a positive AB squared. I have A squared B, negative AB squared, and a positive B cubed. And our final result, if we look inside the box, A cubed. Now, if you look along the diagonal, you usually see like terms. So I have 1A squared B minus 1A squared B. Those cancel. I have negative AB squared plus AB squared, and those cancel. And then I'm just left with B cubed. So when I distribute and simplify, I do get back to A cubed plus B cubed. Let's continue on. How can you use the identities to multiply this expression? Let's take a look. I'm going to write this 2 times because my power says to do that. And I'm going to make a box. So again, I can distribute, or we can make that box. So outside I have a positive 2x squared and a y cubed. Out over here I have 2x squared and a y cubed. I'm going to multiply outside and add on the inside. So we have in this box 2 times 2 is 4, x squared times x squared is x to the 4th. Here I have 2x squared y cubed. Over here I have 2. I'll always write the x first. X squared y cubed, just because it might be easier to find like terms. And over here I have y to the 4th. Now we add on the inside. So we're scanning for like terms. So we have 4x to the 4th. I have 4 of the x squared y cubes, and I have y to the 4th. So that's my final answer. For the next example, it says, how can you use these identities to factor polynomials and simplify the expressions? So we're using those formulas. Here, I see the difference. I know it's either going to maybe be difference of squares, a squared minus b squared, or I know it has to do with cubes, possibly a cubed minus b cubed. Let me think about it for a sec. First, let's see if there's a GCF. 9 is only divisible by 3, 9 and 3. 25 doesn't divide by either of those. Okay, so it's not going to be, there's not going to be a GCF. I'm going to try the squared formula. So I'm going to do parentheses squared. What number squared gets me 9? So that would be a 3. What squared gets me m to the 4th? That would have to be m squared, right? Because m squared times m squared is m to the 4th. Then in the next slot, remember you keep your negative in the middle. What squared is 25? That's a 5. What squared gets us n to the 6? It's n to the 3rd, right? Because n to the 3rd times n to the 3rd is n to the 6th. You add those powers. And if you're not sure, the power means you have 3 of them and you have 3 more, and in total you have 6 n's. Now that we can fill that formula, so to speak, we know what a is, we know what b is. If a is 3m squared and b is 5n cubed, the formula says a plus b times a minus b. So in the a slot, we'd have 3m squared. In the b slot, we have 5n cubed. A slot, 3m squared minus b, 5n cubed. And that will be our final answer. Let's look at this next one. So for this next one, we're thinking about the cubes. So let's think about this. So what cubed gets us x cubed? X. What cubed gets us 216? Let's see. 12. Let's just play around with it. 12 times 12 is 144 times 12. That's way too big. Let's try 3. 3 times 3 times 3 is 27. Nope. 4 times 4 times 4. This would be 16. And 16 times 4 is still too small. 5 times 5 times 5. 25. We'd get 25, and 25 times 5. Nope. 6 times 6 times 6. So let's see. 6 times 6 is 36, and 36 times 6 is 216. So we know it has to be a 6. So we have an A, B. So now that we know A and B, let's try to use our formula. So this is A, B, A squared, A, B, B squared. The signs are SOAP. So the first one, S, means same. So if it's a subtraction, we do minus, same. The next is opposite, plus. Last is always positive. There's only going to be one negative in the cube formula. So in the A slot, we'll write a x. In the B slot, we'll write a 6. A squared. A squared is x times x. So that's x squared. AB is x times 6, which is 6x. And b squared, if b is 6, 6 times 6 is 36. So that would be our answer for that problem. I'm going to pause and I'll have